Alright, so we are going to start solving problem number 9 on this polynomial inequalities worksheet. I do believe this is the one you were needing help with. If it's not, let me know and I'll do the number 9 from the other worksheet or something like that. But this one's a little different because unlike these others, it's not a polynomial. Now this is actually a good thing because you always want to turn these into binomials, into the form this is currently in. So we already have this pre-simplified. We want to figure out what each of these binomials would be to make it equal 0. Since we have 0 on this side of the equation, then we can set each of these equal to 0, figure out what x would be, and solve from there. So in this case, of course, x would be -5 if we set that first one equal to 0. X would be 2, x would be 1, and x would be -1. So we're going to create a number line here. And I'm going to put these different numbers on it. So I'm going to have -5, -1, 1, and 2. So just like on the other problems, we're going to choose a number in between each of these, or in each of these intervals, as you want to say. So a number lower than -5. Let's choose -10, because 10 seem to be kind of easier to work with. In between -5 and -1, let's say -2. In between -1 and 1, we can do 0. In between 1 and 2, we have to choose a not real whole nice number. We'll do 1.5. And after 2, let's just do 3. You can do any numbers you want. These are just the ones I'm going to go with. So in this problem, it does look a little bit differently for plugging the numbers actually back into the problem. Because in this case, we don't have just that big long equation we can plug it into. Now, if you wanted to FOIL this whole thing out and plug it into a big long polynomial to the 4th degree, you can. But I wouldn't recommend doing that. I would recommend instead solving these one by one by plugging in our chosen value for each x. So let me erase these numbers here, so we have a little bit more room. And so if I plugged in, let's do 0 first. 0 is the easiest number to deal with. So if I plug in 0, I'm going to get 5. If I plug in 0, I'm going to get -2. If I plug in 0, I'm going to get -1. And if I plug in 0, I'm going to get +1. Now what I'm going to do is I want to look at what this is going to equal. Like we said on the rational inequalities video, we're not necessarily looking for a number, but we're looking for how it relates to 0. So we kind of just want to know whether it's positive or whether it's negative. So a positive times a negative makes a negative. A negative times a negative makes a positive. And then now our number's positive times a positive is going to stay positive. So is this going to be less than 0? No, unfortunately it is not. So that means our 0 interval right here is not going to work for our equation. Let's try out some of our others. Also, apologies, our dog is yelling in the background because she wants dinner that we are eating, but she will have to wait a moment. So let's try out, I don't know, -2. So if I put -2 plus 5, -2 plus 5 is going to be +3. -2 minus 2 is going to be -4. -2 minus 1 is going to make -3, and -2 plus 1 is going to make -1. So for -2, I have a positive times a negative, making a negative times a negative, making a positive, and that positive times a negative again, making it negative. Is a negative going to be less than or equal to 0? Well, not or equal to, but less than 0? Yes. So that means that interval for -2 here is good. That is a fantastic interval for us. So we are going to skip back once more. We're going to do a couple of these other ones. Let's try out -10. So -10 plus 5 will be -5. -10 minus 2, -12. -10 minus 1, -11. -10 plus 1, -9. If we have 4 negatives all multiplying together, we're going to end up with a positive number. Again, it doesn't actually matter the number we end up with, but it's going to be positive, which is not less than 0. So this interval does not work. Now at this point you may kind of notice a little bit of a pattern. You know, it may be a little early on to say that per se, but there is one. You'll see that these alternate in whether or not the intervals work. No, yes, no. So we can probably guess this is going to be a yes, that's going to be a no, right? But let's make sure that we are correct about that. 1.5. 1.5 plus 5 is going to be 6.5. 1.5 minus 2 is going to be negative 0.5. 1.5 minus 1 is going to be positive 0.5. And 1.5 plus 1 is going to be 2.5. So we have a positive times a negative, which will make a negative, times a positive stays negative, times another positive stays negative. So we're looking for a negative number for our good intervals. This one is good. All right, I'm going to clear this out, and we're going to do our last step to this problem. We are going to deal with that 3. Go away, Dot. Go away. There we go. Come on. Oy. There we go. Perfect. All right. So when we have 3, 3 plus 5 is going to make 8. 3 minus 2 makes a 1. 3 minus 1 makes a 2. And 3 plus 1 makes a 4. All of these are positive, so ultimately all of our answers, or our overall answer is going to be positive, which is not greater than 0, making this bad. Again, you'll notice this kept that alternating works, doesn't work kind of pattern, and we have only 2 intervals that do work. So when we're writing our interval notation, we're going to start with our absolute lowest number, negative 5 in this case. It is going to have a parentheses because this is not an or equal to problem, and it goes all the way up to negative 1, and it's also going to be in parentheses. We have a union because we have a break in the domain, and then we start right here again with 1, and we go up to 2. And these are the only 2 intervals that actually fulfill our problem. So this is how we would solve it. The biggest key is just keeping in mind you need to make an interval for every different 0, or every different root as we call it in our problem, the answers to each of these binomials, and then to just plug in our values for x. If you have any other questions, let me know and I'll be more than happy to help.